Okay, we have come to the last part of the midterm review. So, first question, simplify the expression tangent theta, sine theta, cosecant theta, cosine theta, secant theta. So let's go ahead and do this problem here. And this is actually a little bit simpler than some of the methods that you may have been using. What you really want to do here is look for reciprocals. And of course, this is going to come from your blue sheet of paper, your blue formula sheet. So let's take a look at our reciprocal identities real quick. And here's our reciprocal identities. So we know that sine and cosecant are reciprocals of one another. Cosine and secant are reciprocals of one another. Tangent and cotangent are reciprocals of one another. If you multiply something by its reciprocal, then we know that it becomes 1. So let's look here to see if we have any reciprocals. And the first one we see is sine and cosecant. So these two are reciprocals. If that's the case and we're multiplying them, we know that we can cross this out because it becomes 1. Secondly, we have cosine and secant. So we can go ahead and cross those two out. And all we're left with is the tangent of theta, and that's it. Now, if I were to do something like add a cotangent to the problem, then we know that tangent and cotangent, they are reciprocals. They cancel each other out. So the solution would be 1 in that case. But we don't have that, so let's go ahead and erase that. Just wanted to make that clear. All right, so next up, it says simplify the expression. Sine squared theta, and then in parentheses, secant squared theta plus cosecant squared theta. As soon as you see that you have parentheses here and we have a function squared, then you want to take a look at your Pythagorean identities. So let's look at those. Now, there's no Pythagorean identity that says secant squared plus cosecant squared. Let's go here and take a look. Not one of them has secant squared and cosecant squared. So what's inside the parentheses here is not a Pythagorean identity. There's no Pythagorean identity that has both of these two. So what we have to do here is distribute sine squared. Okay, let's write it out. So I'm going to get first sine squared times secant squared, and then plus sine squared times cosecant squared. Now, from the problem that we just did, sine and cosecant are reciprocal identities. So if you multiply something by its reciprocal, I can cross it out. Now, don't say that this is 0 or it goes away. Sine squared times cosecant squared is 1, and you have to put that 1 down. Don't just cross them out and leave it. Now, next up, we have sine squared and secant squared. So sine squared, I'm going to leave it exactly the way it is. But secant squared, I'm going to change that into, remember we'd like to rewrite everything as sine and cosine, so we're going to change it into 1 over cosine squared, because we know that secant and cosine are reciprocals. So next up, we can put sine squared over 1, and there's nothing that we can cross out, so let's multiply straight across. Sine squared times 1 is sine squared. 1 times cosine squared is cosine squared. And let's take a look at our identities here, and we know that sine over cosine is a quotient identity that's equal to tangent. So we know that sine squared over cosine squared is tangent squared. Now, on the answer choices on the midterm, you will not see tangent squared plus 1, and there's a reason why, because you can keep going. Let's go back to our identities. If you notice, tangent squared plus 1 is secant squared, so you have to write that tangent squared plus 1 is equal to secant squared, and that is your answer. Okay, so next up, our last problem. Simplify the expression cosecant squared x minus 1 times secant squared x. Now, first, of course, in the parentheses, we want to look at our Pythagorean identities to see if we have one. There's no Pythagorean identity that has a minus 1 in it, so this right now is not a Pythagorean identity. But if you look, this Pythagorean identity here has two pieces of what was inside the parentheses. It has a 1, even though the 1 is positive, and it has cosecant squared. So I'm going to write that down. 1 plus cotangent squared equals cosecant squared. What I want to do is manipulate this identity so that it looks like this one. And in order to do that, we just said the 1 is positive. I don't want the 1 to be positive. I want the 1 to be negative. So I'm going to subtract 1 and subtract 1. So this becomes 0. We bring down cotangent squared x. And on the right side, we have cosecant squared x minus 1. And I'm going to circle that. If you notice, this is now the same as what's inside the parentheses. What this means is I can replace cosecant squared x minus 1 with cotangent squared x minus 1. So let's write cotangent squared x times secant squared x. What I did was replace cosecant squared x minus 1 with cotangent squared x. Now, once again, you will not see this as an answer choice in your answer choices in the midterm because you have to keep going. Cotangent squared and secant squared, we're going to change everything into sine and cosine. So cotangent squared, from our blue formula sheet, we're going to rewrite it as cosine squared over sine squared. Secant squared, I'm going to rewrite that as 1 over cosine squared. We have a factor of cosine squared up top and a factor of cosine squared on the bottom, so we can cross those out. We're left with 1 over sine squared. Now, you may be thinking at this point that you're done and I can choose this answer. However, this will not be one of your answer choices. And the reason is you can't leave this as a reciprocal. This has a 1 on top, so it's a reciprocal. So if we go to our identity formulas here, our reciprocal identities, we know that 1 over sine is cosecant, so 1 over sine squared is cosecant squared, and this will be your answer choice on the midterm. And this concludes our midterm review.